Civilization is a limitless multiplication of unnecessary necessities. Hi and Hariom. A very happy new year to all of you children. Today's topic is decimal multiplication. Shall we start the session with prayer? Sit straight, close your eyes, take a deep breath, chant Om 3 times, followed by prayer.
सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरि ओम् श्रीगुरुभ्यो नमः हरि ओम्.
Here is the learning objectives of multiplication of decimal numbers. To know the effect of multiplying numbers by 10, 100 and 1000. To be able to multiply and divide numbers by 10, 100 and 1000. To use understanding of place value to multiply and divide whole numbers and decimals by 10, 100 and 1000. In this video, we will see only about multiplication of decimal numbers. Naming decimals. Decimals are a method of writing fractional numbers without writing a fraction having a numerator and denominator. The fraction 7 by 10 could be written as the decimal 0.7. The period or decimal point indicates that this is a decimal. The decimal 0.7 could be pronounced as 7/10 or 0.7. If a decimal is less than 1, place a 0 before the decimal point. Write 0.7, not 0.7. Multiplying decimals. Multiply decimals using the same procedure as with whole numbers. Count the number of decimal places in both the multiplier and multiplicand. Begin counting from the last digit on the right of the product and place the decimal point the same number of places as there are both in the multiplicand and multiplier. By the end of this video, students will be able to multiply using models, multiply decimals by decimals.
models. In math, it is important to conceptually understand what exactly a math problem is asking you to do and what the answer means. Models can help us build our conceptual understanding. Let's look at how to multiply decimals using a model. Our first problem that we're going to look at is 3/10 times 7/10. When multiplying decimals using a model, we're going to start by converting our decimals into fractions. The way you read a decimal is the way you write the fraction. 3/10 is equivalent to the fraction 3/10, and 7/10 is equivalent to the fraction 7/10. When modeling multiplication of decimals, we use a grid. For this problem, we will use a 10 by 10 grid because both denominators are 10. If the denominators were not 10, we would need to scale up or scale down so that we could create an equivalent fraction that had a denominator with a power of 10, such as 10, 100, 1,000, etc. Then we could adjust the grid to match the denominator. For example, if the denominator was 100, we could use a 100 by 100 grid. Okay, back to the problem of 3/10 times 7/10. To create our model to help us solve our problem, we're going to start with our first fraction of 3/10. Remember, the numerator of a fraction tells us the parts and the denominator tells us how many are in the whole. Let's use the vertical columns of the 10 by 10 grid to model 3/10. Since the numerator is 3, we will shade in 3 of the 10 vertical columns. Now we can model the second fraction, which is 7/10. This time we're going to look at the 10 rows that make up the grid. The numerator of the second fraction is 7, so we will need to shade in 7 of the 10 rows. Once we are done representing the two fractions on the grid, we're going to look at the double shaded or overlapping area of the grid to find our answer. To write our answer, we first need to consider how many squares are on the 10 by 10 grid to determine our denominator. There are 100 squares on the grid, so that means that our denominator for our answer will be 100. To determine our numerator, we will need to look at how many squares are in the double shaded area. For this problem, we have 21 squares that are double shaded, making our numerator 21. Now we know that our answer is 21 over 100. Since the original problem asked us to multiply decimals, we need to convert our answer back into decimals. 21 100ths is equivalent to the decimal 21 hundredths. Let's do one more problem. 3 times 3/10. Notice this problem has a whole number being multiplied by a decimal. This problem is asking us to find 3 groups of 3/10. Again, let's start by converting our decimal of 3/10 to a fraction. When we do that, we get 3/10. Since our denominator is 10, we will use a 10 by 10 grid. Since we need 3 groups of 3/10, we're going to start by shading in 3 of the 10 vertical columns. This makes up one group of 3/10. The problem wants us to find 3 groups, so we need to create 2 more groups of 3/10. Let's go ahead and do that. We will shade another group of 3 vertical columns, which gives us our second group, followed by the last set of 3 columns, giving us our third group of 3/10. Now that we have our 3 groups of 3/10, we need to look at how many total squares we shaded. Since we used a 10 by 10 grid, we had a total of 100 squares. After shading in 3 groups of 3/10, we have 90 of those 100 squares shaded. This means that our answer is 90 over 100, or 90 hundredths, which we can also write as 9/10.
Multiplication. By the time you get to this bit of mathematics, you already have some cool multiplication skills. You've learned your tables, and you've probably also learned more than one strategy to multiply numbers together. There's one more thing you need to ace multiplying decimals. You need to be able to count. Of course you can do that, so you're going to ace this topic in math. Before we get to that, let's pin down our terms. The number system we use is the base 10 system. It's called the decimal system. But when we talk about a decimal number, we mean a number with a decimal point and some figures after it. A decimal figure is a digit that comes after the decimal point. This number has 2 decimal figures. Okay, now let's get on to the new stuff. We're going to multiply 2 decimal numbers. Here they are. The trick is we multiply without thinking about the decimal points. And then after we've done the multiplication, we put the decimal point back in at the end. And that's where the counting part will come in. We start off thinking about these significant figures, the 2 and the 6. We multiply them together. Of Of course, that's 12. And now we put those decimal places back into the answer. In the original numbers, we've got 2 decimal figures here and 1 here. And we need 3 decimal figures in the answer. I only have 2 figures right now. Not a problem. I write a couple of zeros in front of my 12. Starting from the right, we count to the left. 1, 2, 3 figures, and here's the decimal point. 0.012. I have 3 figures here. We're all done. And that's it. Let's do another one. 0.47 times 11. Ready to go in standard algorithm form this time. I'll ignore the decimal point right now and just multiply like it's not even there. First row, 47 times 1, 47. Second row starts with a 0 because we're multiplying by 110. 1 times 7 is 7 and 1 times 4 is 4. Now add them up. First row, 7. Then 7 and 4 is 11. And here, 4 and 1 is 5. 517. Now we put in the decimal point. Here we have 2 decimal figures, so we need 2 decimal figures in the answer. Count from the right to the left. 1, 2, and there it is. 5.17. 2 decimal figures in the answer, all done. Pretty simple, right? Don't stop now though, because there's a special case to watch out for, like in this example. Always focus on the multiplication first. 2 times 5 is 10. Notice it ends in a 0. Okay. Now we put in the decimal figures. 2 figures here and 1 here. 3 decimal figures to go in the answer. Put some zeros at the front. Now count. 1, 2, 3 figures. The decimal point goes here. 0.010. Hang on a moment. We know that we don't need that 0 at the end. It's just a placeholder. So there's one more step to show. Equals 0.01. Once you've done this step of putting the decimal point in the right place with the right number of decimal figures, then you can eliminate any zeros you got just hanging around at the end. And in fact, if we'd had this instead, we can eliminate those place-holding zeros before even doing the multiplication. So we're still thinking about 2 times 5, and we still have 3 decimal figures, and the answer is still 0.01. You can check this out on your calculator at your own pace. I think you'll have fun with it. It's strong stuff. Next time, I'll show you how to estimate your answer. This is cool because it lets you check your work and be able to give an estimated answer, because that's sometimes what a problem tells you to do. I think being able to use different strategies to solve a problem makes you stronger. In this video, I'm going to show you 2 shortcuts to solving a problem multiplying decimal numbers. You can't use them all the time, but when you can, it's great. You've done lots of work on fraction and decimal equivalents by now. You know some key equivalents, like these. 0.5, 1/2. 0.25, 1/4. 0.33, that's 1/3. 0.1 is 1/10. 0.2 is 2/10, and that's the same as 1/5. Notice all these numerators of 1. If you can spot an equivalent fraction with a numerator of 1, you can blast through a problem. Check it out on this example. 0.5 times 26. So far, we've just gone straight for multiplication, but we could do this another way. We know that 0.5 is 5/10, and that is the same as 1/2. So we can rewrite this problem as 1/2 times 26, or half of 26. Can you do that in your head? It's 13. I used mental math to do that. Nothing went on paper, and it only took a moment. If I did this on paper, I'd do 26 divided by 2. Now let's compare that with multiplication and see if we get the same answer. We want the significant figures 5 and 26. 5 times 6 is 30, and 5 times 2 is 10, plus this 3, 13, 130. We have one decimal figure, so that gives us 13.0, just the same as plain old 13. That took quite a bit longer to get to the same answer. Now you can see why it's cool to know this strategy too. What about this one? 0.2 times 55. Think about the fraction equivalent. 0.2 is 2/10, and you can reduce that to get 1/5. Now you have 3 possible strategies. 2 shortcuts or multiplying it out. First, we could rewrite the problem as 1/5 times 55. We want 1/5 of 55. We can do 55 divided by 5, and that's 11. And here's the second shortcut. If I put that 55 over 1, I can treat this like a fractions multiplication. I've got 2 ways to work. I can reduce first and multiply out. So this becomes 1 and this becomes 11. Multiply across and we get 11 over 1, or just 11. Or the second way we could work here is to multiply first and then reduce. Set it up again, and multiplying across we get 55 over 5. When we reduce, we're dividing. This means 55 divided by 5. Here we get 1, and up top 11, and of course that also equals 11. You could also choose just to multiply it out. 2 times 5 is 10, 2 times 5 is 10, and this one, 11, that's 110. There's one decimal figure here, so we put that in the answer, 11.0, which is just the same as 11. We get to the same answer, but it does take longer. If you get a problem where you can spot a fraction equivalent and the numerator is 1, like in my examples in this video, then you can use one of these 2 shortcuts. I think this is very cool. We're learning about multiplying decimals, and we just made math connections to our knowledge of decimal fraction equivalents and fractions multiplication. This gives you options for how to work. It helps you build math muscle and confidence, and that's really important. Go for it. Try these shortcuts to solve some problems multiplying decimals. See you soon.
Alright, what we're going to do today is we're going to practice creating an area model to represent a given decimal multiplication problem. So let's start with 0 and 7/10 multiplied by 0 and 8/10. Now remember, a value less than 1 whole can be considered a part. So what we really have in this instance is a part being multiplied by another part. And remember, a part of a part is just going to result in a smaller part. Now when creating an area model, we should reference back to the area of a rectangle, which we know can be found by multiplying the length by the width. So one of our 2 numbers should represent the length of our model, and the other number should represent the width of our model. So what we're going to do is we're going to start off by letting 0 and 8/10 represent the width of our model. So we're going to go ahead and shade 8/10 of our figure. Okay, so we have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, and of course 8/10. Okay, now what we have to do is shade what will be the length of our figure. So let's go ahead and shade 7/10 of our figure. So we have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, and 7/10. Alright, what we're going to do now is we're going to take those 2 portions that we shaded and overlap them together. And the part of our areas that overlap will actually represent the product of our 2 numbers. Now remember, each individual square represents 1/100th of a whole. Now, if you were to count everything that was inside the red borders, we have 56 of those squares. So we have a total of 56 hundredths, which is the product of 0.7 and 0.8. Okay, let's multiply 0 and 4 tenths by 1 and 2 tenths. So we're going to start by creating a model that represents 1 and 2 tenths. So we're going to let that represent the width of our figure. The blue area represents 1 whole, and the orange area represents 2 tenths. Now, taking a look at only the edge that represents the width, that width is a distance of 1 and 2 tenths. Okay, now that we have our model that represents 1 and 2 tenths, we must understand that we're multiplying that by 0 and 4 tenths, which is less than 1 whole. So basically, we are only trying to figure out what part of 1.2 is. So that means we are only going to shade part of the model that we see. Okay, so what we have to do now is mark off 4 tenths that would represent the length of our rectangle. So we are not allowed to shade anything below that point. Okay, so if we were to count everything inside the border that we just defined there, we would have 48 squares, and each square is 1/100th, and 48 groups of 1/100th is 48 hundredths, which can be expressed as 0.48. All right, now we're going to multiply 2 and 3 tenths by 2. First, let's start with the width of our figure. So here we have 1, 2, and 3 tenths. All right, now because we use 2.3 to represent the width of our model, we have to use 2 to represent the length of our model. So we have to go a distance of 2 up and down. So basically in this example, we have 2 groups of 2.3, which we can clearly see on the screen. Now, let's take each one of these sections and add them together. We have 1, 2, 3, 4, 4.3, and 4.6. So a few things that we should keep in mind here. Whenever you are multiplying two values that are less than 1 whole, such as 0 point something times 0 point something else, the result will always be less than 1 whole, which means you will always shade less than 1 whole of your area model. Now, if you are multiplying a value less than 1 by something greater than 1, that means you are going to be shading part of something that is greater than 1. And when multiplying two values that are greater than 1, that just means you're going to end up with more than what you started with. You are not going to shade part of anything. You're just going to add on to what you already have.
Multiplication of decimals by 10, 100, 1000. Hello kids! Today we shall multiply decimals by 10, 100 and 1000. So let's begin. Let's take the decimal 3.146. When we multiply a decimal by 10, we shift the decimal point one place to the right. Thus, 3.146 into 10 is equal to 31.46. In the same way, when we multiply a decimal by 100, the decimal point shifts two places to the right. Thus, 3.146 into 100 is equal to 314.6. Similarly, when we multiply a decimal by 1000, the decimal point shifts three places to the right. Thus, 3.146 into 1000 is equal to 3146. Remember, to multiply by 10, 100, 1000, shift the decimal point as many places to the right as there are zeros after 1. Now, let's solve a story problem. The length of a ribbon is 2.58 meters. What is the total length of 1000 such ribbons? Let's write the statements first. The length of one piece of ribbon is equal to 2.58 meters. Number of such pieces is equal to 1000. Therefore, total length of 1000 such pieces is equal to 2.58 into 1000. On multiplying, we get the answer as 2580. Thus, the total length of 1000 such pieces is 2580 meters. Wasn't it easy? Multiplying by 10, 100 and 1000?
Multiplying decimals. Imagine the values without decimal points. Multiply them together. Count the number of digits that came after the points in both of the original numbers in the calculation. From the right to left, count that many digits in your answer and write it in your decimal point. Check your answer makes sense using rounded values for the original values in your head. Here is a recap of multiplication of decimal numbers. The rules of multiplying decimals are: take the two numbers as whole numbers, remove the decimal and multiply. In the product, place the decimal point after leaving digits equal to the number of decimal places in both numbers. Counting decimal point must always be done from the units place of the product.
Sit down on the ground comfortably. Without moving your head and neck, look upwards and then downwards. Keep your neck and back straight. Now look at the sides alternating with the left and right. Do not move your neck while looking sideways. Now look to your left, then look upwards. Move your eyes right and then look down. Look upwards, to your right, and then down. Now look upwards, then to your left and down. Now alternatively, look to your left once after looking upwards, before looking down, and then look to your right the next time after looking up. Close your eyes and rest for some time. Sit comfortably and bring your hands straight forward at shoulder height and raise your thumbs. Look at your thumbs. Slowly spread apart your hands. Look at your left and right thumbs alternatively while spreading your hands apart. Bring your hands together, continuing to look at your left and right thumbs alternatively. Close your eyes and rest for some time.
आशिष्यते। ॐ शान्ति शान्ति शान्तिः। हरि ओम श्री गुरुभ्यो नमः। हरि ओम।